All right, guys, so in this video, we're going to continue on with modeling with equations, and we're going to do a mixture problem, okay? So a manufacturer of soft drinks advertises their orange soda as naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice, okay? So let's say this soft drink manufacturer has 900 gallons of the soda that they've created, and in order to meet this regulation, they need to go up to 10% fruit juice, okay? How much pure orange juice are they going to have to add to this 900 gallons to meet this regulation, okay? So this is what we call a mixture problem. We're going to mix different amounts of objects, and we're going to come up with a total mixture or concentration of this soft drink to meet the criteria, okay? So first thing we want to do, our 900 gallons that we start with was 5% OJ, okay, just to meet the previous criteria. And we're going to add to that another container of just orange juice. There's no soda in here. It's 100% OJ in the second container. We're going to mix these two together to create a container of soda that is 10% OJ to meet the criteria, okay? So we've got 5% OJ in the first container, we've got complete OJ in the second container, and when we mix those together, we want to end up with a 10% concentration of OJ in the final container of soda, okay? So let's talk about volume first. In the first container, we've got 900 gallons of the soda, all right? In the second container, we don't know how many gallons. That's actually what we're trying to answer here, okay? So we've got X gallons of OJ, 100% OJ in the second container. And when we get finished, we're going to have whatever 900 plus X is, okay? So now let's talk about the concentration. So in the first container, we've got 0.05 or 5%, written as a decimal is 0.05. Out of that 900 gallons is OJ. So that comes to a total of 45 gallons of OJ in the first container, okay? The other 855 gallons is soda, okay? In the second container, it's 100% of its OJ, so it's just going to be X gallons of OJ in that second container. So when we finish up, we're going to want 10%, which is written as 0.1 times the number of gallons, which is 900 plus X, okay? So when we distribute here, we get 0.1 times 900 is 90, 0.1 times X is 0.1X, okay? So my model is going to be the amount of OJ in the first container plus the amount of OJ in the second container equals the amount of OJ in the mixture, okay? All right, so let's plug in what we know. So amount of OJ in the first container is 45 gallons. Amount of OJ in the second container is X gallons, and that's going to be equal to the amount of OJ in the mixture, which is 90 plus 0.1X, okay? So this gives us a pretty easy little linear equation to solve. I'm going to get the x's on the left side, the constants on the right side, and I get 0.9x equals 45, okay? And when I divide 45 by 0.9 to get x by itself, I get 50 gallons, okay? So this soda manufacturer is going to have to add 50 gallons of pure OJ to the first container in order to meet the new federal regulation to have 10% OJ in order to be called natural, okay? So that's how you set up and solve mixture problems.